Okay, good morning. The name is Mr. Madondo, and I'll be taking you for logic design and switching circuits. This is your course outline. I think for students who are in electronic and telecommunication department, you have it. For the course objectives, my course objectives. Today, I'm more concerned with the course outline. Part 1, I'll introduce you to logic design, why we do logic design. Mute yourselves, please. Ndikaramba ndichimute vanhu apa ndikubudisa vanhu. Kana muri kundinzwa vana mauya ari kuti anoisa muri kubuda. I think there are a lot of people here. Learn to mute yourselves muchisvika panzvimbo. Vatoridza radio zvako. Vari kuridza radio avo ka muri kubuda, and if once you are removed you cannot come back. I'm sure you know that. Thank you, Kundai. Guys, mute. Right. I don't think it's my job, but you need to know, you need to mute yourselves. Right. Course outline. I'm going to introduce you to what a logic design is, and why we are doing this course. Then I'm going to introduce you to my number systems. I think the concept is a part 1 today. Yeah, it's not possible, but I'm hoping we do. So, what is logic design? How do I participate? There's a thing about participation. Kind of lecture. I always say when you participate, you get noticed. When you get noticed, my negotiation and my marks is it gets easier. Because it can be difficult for 300, but onekera because ukaonekera chero pakumanga chaipo ndokuziva ine maidea enyu manzi machi registration number. I know everyone. Onekera, you need to participate. I have a question. Can you please help us by recording the lecture? Yes, I'm recording. I think so. Yes. So participation. You need to participate. Digital systems. What is a digital system? What do you understand by a digital system? Logic design is all concentrated on the digital systems. That is where logic design is. Definition, logic design. Anyone to get us into the logic design, starting with definition of digital systems. What is a digital system? Arguda, one of our privileges is a participation. Brian Masoka.
It is the basic organizational circuitry of a digital computer.
Of a digital computer, right? Digital circuits, in short, those systems are a computer. Computers, they use a digital system. The circuitry system is a digital system in place of an analog system. Why we are doing logic design? Is to learn representation signals array digital. Why? Because we are now living in a digital world. We have more computers all over the place. The way the data is represented, it is in digital form, and that is what we will be focusing on this course. Forgive me for being a bit jittery. I think I'm but I have new toys here. I have new toys I'm using, still getting used to them. So at the same time, I will deliver a lecture. I'm also learning how to manipulate my trace and then open. So forgive me for being all over the place. But trust me, the gear, everything will be voila. Right, a digital system. It is a system that manipulates discrete elements or of information represented in binary form. So when we talk of logic design, the starting point here do digital systems. In telecommunications, I'm not sure in computer engineering, how does it fit? But in telecommunications, we have a system. You wanted to transmit information from point A to point B. Information can be, for example, this sound. Position B, we have my students. How we transmit information up. This is what we call telecommunications. We have my transducer. We have a transmitter. We have channel receivers. Then we have point B here. So from point A, we have sound edu, spin down transducer. We have electrical signal, spin down transmitter. We have another signal here suitable for the channel, spin down channel. Then we have noise, channel. We have receiver, noise and demodulation. For telecommunication students, it's very unfortunate for computer engineering. I don't have the right approach. The logic design, where does it fit? Computer engineering is very unfortunate. But I think on the telecommunications, where I'm best, you get a better understanding of why we're doing this. Next year, maybe the goals go away before we get on the computer engineering. I'll give an example of where it fits. Right. Demodulation, transmitter, modulation. This is a telecommunication basic communication system. Right. Sound edu, this is a signal. It can be represented as an analog or a digital signal. If it's an analog signal, in a transducer, it is converted into an electric signal, or transmitter. For example, I'm familiar with my optical fibers. Transmitted optical fibers, your signal is modulated with the light, with the light source. Then you pin channel yako optical fiber. Then you pin receiver demodulation, and you have sound wherever you are a student from Mr. Madon. My courses edu ese anotendere on this basic communication system. So for transducer, my components are capacitors, transistors, and all those electronic things. I'm sure my name is communication and devices. Cannot first year pan kwa maka dosit. Transmitter my components pan kwa maka there's a course for that. Pamagaita to components to big good. We have channel. There's a course for that. Specifically, there's a course in optical fibers. A channel can be wireless. It can be wired. We have microwave, radio wave, another wave, optical fibers. We have coaxial cables and all that. There is a cause for all that. There's a cause, yamuneta modulation, from transmitter panel, yamuneta demodulation. There's a cause, yamuneta how to convert a signal from analog to digital, ADC, sampling and quantization. This course is more concerned with how do you represent this digital form. This course, what's the right word, Rachel? This course involves how we represent, This course involves how we represent the digital part of the signal. So definition, analog signal. My analog signals, we have something like this. Pakaitka ADC, we have something like this. You need to be familiar in the sense of it. If we code this signal, we have 1 0 1 0 1 1 0 0 representation of a signal. We call this binary. There's a process you go to know analog, analog, what about discrete time signal? Then we end up with binary. There's a process and there is a course which takes you through that process. Kana musuru is what course ichi. That is for you to learn is because there is no need to get at this because also the background. Why are you doing it? It's important to put exam which pass, but it's a thing. Chandakawan and the university, everything. But you need to understand what you are doing. You just don't need to go to university to get a degree. Also, result it's possible. But in any, I would really love it if you understand why are we doing synthesis activities. I would really love it because unfortunately I didn't have that chance. Don't work my numbers. They work my binary. I don't work. But it was very difficult to understand until maybe this point. Most of the things, why are we doing this? So I need to emphasize on this. As much as you want to pass, you also need to understand the so I just gave you a picture from a telecommunications point of view. But why are we doing logic design? It's because telecommunications, it involves my signals. My signals at one point, the world is digitalizing, they need to be digital. How do you represent my signals when they are digital? That is what we call logic design. In the switching part, we'll get to it later on. Right, feedback. Someone to respond.
Yeah, Trugunza.
Thank you very much. Right, we have analog versus digital. Analog versus digital. Right. Analog systems, they process information that varies continuously. Digital systems manipulate discrete elements. Definition. Analog signal, they process signals that vary continuously. Discrete time signals, they process signals that vary discretely. All right. Representation analog digital signal ndio irapo. Voila. This is the same signal. But this signal, the analog, it is continuous in time. What do we mean continuous in time? It means for any given point, there is a corresponding value here. That signal, there's a corresponding amplitude for any given value term. There's a corresponding amplitude. The guy up, there's a corresponding amplitude. It means it is continuous in time. We have a discrete time signal here. It is not continuous in time. It is discrete in time. It means the guy up time point, you know, I'm going to pass a signal up. There is no amplitude. So it is not continuous. It is defined for certain points. It is defined for certain points. You need to understand the difference between analog and digital signal from representation. All right. Why digital systems? Why do we use digital systems? Participation. What participate? Farai. I noted, I think it was Farai something. Who participated back then? Farai who? And by definition, a digital system is Farai. It doesn't want to show up. Okay. Benjamin Masok. Yeah, that's the one. It wasn't Farai. All right. Why digital systems? Anyone to help? Benjamin Masoka, congratulations. Manima privileges, comrade. Benjamin Masoka. Why digital systems?
Yes, I would want to add on to the reason why we use digital signals. It is because the digital signals, they are immune to noise interference.
All right. Jeremiah Mutazondida, final warning, mute yourself or Murubuda comrade. All right. Why we use digital signals? Immunity to noise. Can Muruda Chaura unmute yourself? If not, Jeremiah, do you want to say something? Jeremiah, out. Right? Who else? Why do we use digital systems? Because they are easy to design. We have praise Zininga. Congratulations, Manma privileges, wherever you are. Easy to design. Anyone else?
Yes, sir.
Digital systems, they have low power consumption. Hence, their use power is expensive.
Low power consumption. Rafa?
They're also accurate and precise, and they're easier to maintain throughout the system. And once the signal is digitized, the information is it contains and does not deteriorate as it is processed.
Okay, got me right. Right, there are a lot of reasons why we use digital systems. To note, Ndoma Shomata, Atapi and Makomrez, Mr. Masoka, Mr. Wafa, Mr. or Mrs. Zininga. I'm not sure. You need to know why we are digitalizing. That's why we are doing this course. You need to know why we are digitalizing. And those are some of the reasons. You also need to explain why. I think the one and the low power consumption, he explained why my digital systems, they have low consumption, power consumption. You need to know why. I'll give a few examples of the reasons why we are digitalizing, explaining them a bit. We have ease of programmability. Ease of programmability. Ease of programmability. Right, systems can be used in different applications by simply changing the program, but not changing the hardware. Ease of programmability. For example, my software is that inoshandisa operating system, CPU yedu, monitor yedu, ndikaisa operating system Windows 7, ndikaisa operating system Windows 10. I don't need to change anything for hardware. I just change the program it will run a system. That is one of the most important reasons why we use my digital systems. For analog systems, you can have a case kuti moto change system a program or something like that. You have to change everything, the whole hardware for analog systems. For digital, however, I have a perfect example. Your computer I can run Windows 7, I can run Linux, I can run all those other programs using the same hardware. Ease of programmability. You need to know the reason and explain it. Those are typical exam questions. Exam. Those are some of the questions. We have a reduction in cost hardware. We have a reduction in cost of hardware. Due to advances in IC, integrated circuits, due to advances in IC technology, we see the number of components that can be placed in a given area is increased. All right, my IC circuits. You realize that you could dara memory card. Not memory card per se, but storage. It was probably this big. Storage 1 gig. In fact, it was as big as this room and didn't know. Probably the whole building. Mashuroko. But today I can store 1 gig on something like this. The reason why you have a memory card, it is because of digitalization, digital signals. Reverb. Mute yourself or mozona mapans. Who is that? Okay, he has muted himself. All right, back here. I said reduction in cost of hardware. Due to digitalization, we have my components are much smaller than before. The reason why is because of what we call my integrated circuits, ICs. You need to know what is an IC. My chips stores memory and do a lot of things. Reduction in cost of hardware. Why? Because of introduction in my ICs. Why? Because some digital systems. Another reason why we use digital systems, we have high speeds. Digital systems, they offer high speeds. This is mainly because of advancements in digital signal processing. As it is, we have another course in digital signal processing. My advances in that course of digital signal processing research in that area of digital signal processing, it has led to higher speeds because instead of using my analog signals, if you replace them with my digital signals, those effects, the noise, it leads to higher quality. System it offer more speeds, it offer also higher capacity, more bandwidth, and other stuff. We have high reliability and accuracy. Reliability and accuracy. Kana tishandisa ma-digital systems, tishandisa ma-digital signals, we have anonzi ma-error codes. It means ukaisa ma-error codes in system mako, they correct ma-errors. So the use of error codes means system yako, it is more reliable. There is a lot of prediction in it kana tichisenda information from one point to another point. A lot of probability and statistics involved. And when you predict something, it's not always you are correct. And it leads to errors. However, in digital signal processes, we have error codes which help in minimizing those errors. I made a prediction here, messaging. We have also ease of fabrication and storage of data. My digital systems, they are very easy to fabricate. Those are some of my reasons why we are digitalizing. Right, we have disadvantages. That is for you. Add a little beef, more some disadvantages. Yeah, they produce more heat, they are fragile, blah, 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 blah. Research, disadvantages. You need to know as much as my digital systems, they have their pros, they also have cons. You need to know what are those cons and explain them. All right. And the number systems. So basically what I've done, Panapa, is introduce logic design and switching circuits. Why we are doing it. It's more centered to we are digitalizing, and we need to know how do we represent my digital signals. Let's get into number systems. Number systems. Here they set up. Anyone to comment? There's a comment.
Yeah, yes.
Right. One no computer engineering. I just need to know if we have. Thank you very
Yes,
much.
yeah.
Thank you very much.
Ripo.
Right. Forgive me in remote telecommunications. The way I explain this, the way I'm going to explain this course, right, 10 minutes. The way I'm going to explain this course, it is mostly centered on knowledge young with telecommunications. So I think it will be very, not difficult, but it will be unfortunate for one way to engineering, software engineering, maybe to get an insight, but it is what it is. Answer software engineering, but this is logic design. I hope you understand. Right. Study of number systems is important for understanding how data is represented before it can be processed by any digital system. So we are going to be studying my number systems. Why? Because it is important to understand how data is represented. Number systems, they are all about representation of data. How is data represented? We have a couple of number systems. We have binary system. Data can be presented as zeros and ones. I think the most mentioned, sampling and quantization, you can code signal rako. Represent zeros and ones. For example, this signal 0, 0, 1, 1, 1, 0. That is a signal. This signal can also be represented as 1, 0, 1, 1, 0. This is a 1, this is a 0, this is a 1, this is a 1, This is a 0. This is a binary system of representing data. Data read in the E. It can be represented using my numbers I. This is called a binary system. We have a decimal system. Right. Decimal system. Binary system read, it uses zeros and ones. We call it in a base, base 2. We have decimal system in a base 10. I cannot give definition in base, but I hope you understand the term. That's the base 2, base 10. What does that mean? Base 10. These are our numbers 0, 1, 2, 3, 9. Data can be represented using my numbers I 0, 1, 9. We have octal, base 8, octal system. These are number systems used in the representation of data. We have base 16, hexa, decimal system. Octal system, later on. We have this one again, 0, 1 to 9. You've had A, B, C, D, F. So ndoma number systems dealer now binary, decimal, octal, ne hexadecimal. Obviously, there are others. I think so. There are others, but we are not going to be dealing with them. Right. We have number-based conversion. We are going to start with number-based conversion. Information we have my introductory topics like these ones is very important. Convey. And it's crucial when you understand the teaching, because if you get lost here, but now so ma flip flop or ma registers kana makona course outline. So things are gosha. And I'm not ashamed to tell you ndakabva investing as what register don't function as say, but nakari pass. You need to understand, you need to follow my number basis. It might seem like information is some sort of so, but can I build up my registers, my counters? It will be very difficult for you. Believe me there. It was difficult for me. I am teaching this course and I have college and so teaching with it. It happens. Don't let it happen to you, please. Right. Number conversions. Human beings use the decimal number system, whilst computers use the binary number system. This means there is a necessity to convert decimals to other systems. What did I say? Isus human beings. Tunashansa number system the decimal. 0, 1, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. My numbers they don't know by the but my computers, they don't understand my numbers. They can display them. They can display them. That is the manipulation here, data. They can display those numbers. But I must you. What computers know are 1 zeros, 1 zeros. Computers, they know the binary system. So it is necessary to know how to convert from the decimal to binary and vice versa. That's why we're going to be doing my number systems. Right, we have 3 minutes left. I think we have another session. Yeah, I think we have another session. I'm going to end this one so that, but no tanga to tangira pama conversions, binary to decimal, binary to octal, binary to hexadecimal, and vice versa. Right, any comments? Any comments, any questions so far? When you software engineering, when you hardware engineering, when you computer engineering department in general, murukubata direction yetu fambana.
Yes.
Yeah, tirikuzvibata.
Thank you very much. Right, so I'm going to end this meeting in Zemaras Nodura. We restart, I think, after about 5 minutes. Ndapedza convert the video regular to recorder. So that's it for now.
Are we using the same link?
Same link. We will be using the same link until forever. Inshallah.
Oh, okay.
We will be using the same link at change. Right.
All right.